This is practice it exercise 8.21 union rectangle. The problem reads, add the following method to your rectangle class from the previous exercises. So make sure you guys check out the previous exercises before attempting this problem. And this method is supposed to return a new rectangle that represents the area occupied by the tightest bounding box that contains both this rectangle and the given other rectangle. Your method should not modify the current rectangle or the one that is passed in as a parameter. You should create and return a new rectangle. Okay, so let's first start by writing down our method. So public rectangle union, and then rectangle rect, like that, and do that. Okay, and since it strongly emphasizes that we need to modify a new rectangle, we'll start by getting int, and then we'll call it new x, and then we'll call our y int new y, like that. Okay, alrighty, and then we'll define this so that our x and y's are going to be pulling data from our this rectangle. So and then we'll use the min function from math to get the smallest box, because it does require a tightest bounding box, meaning the smallest. So we'll get math.min, and then this dot get x, comma, and then from our rectangle, which is our other given rectangle, we'll pull from that rectangle as well. That. Okay. Then same thing for y. We'll get math.min, and this dot get y, comma rect dot get y. Okay. Alrighty, that's our x and y's. And then now we need to get our height and width. So our height and width have to be our max, right? Because we want the tightest bounding box. So even though our x and y has to be the smallest, our width and height have to be the greatest so that it is the tightest as possible. Okay, so we'll get new int new width, and then we'll get int new height, and then we'll modify those. So int new width, we're gonna apply the same logic we did for our x and y's, except we'll do math.max, and then we'll get rect get x, we'll pull from that, and then plus our rect get width. So because our width accounts for our x and our width, and then to get our width we need to add our x and our width, and then we need to subtract all that by our other rectangle called this. So since our given other rectangle has to be the greater value in this case, so we're just going to assume that. So we're going to say from our new x, we're going to get new x, and then this dot get x. So now we're pulling from our this rectangle plus this dot get width, and then we'll subtract that by our new x as well. Okay, so what that is going to do is we're trying to get, I'm saying this a lot, but the tightest bounding box, right? So we get our rectangle from our rectangle rect, and then this one we get our width from our rectangle this. Okay, and then we're subtracting that by our new x values to figure out like the difference between it. And I realize I spelled width wrong here. Let me just fix that. Okay, and then next is our height. We're gonna apply the exact same logic. So what you guys can do is just get everything here and then copy and paste it over here, and we can just modify this. So for our height, we're accounting for y, right? So, and then make sure you guys just fix everything so that it's according. So make sure the x's are y's, and then the width is all height, and then that way it saves us more time. So that will be our height. Okay, and then now just to sum everything up, we now need to return our new rectangle. That is our tightest bounding box. So return, and then we'll get new rectangle, and then they have to pull data from our new x, our new y, and our new width, and our new height, just like that. Okay. And yeah, I think that should solve this problem. Let's run it just to make sure. And yep, all our test cases are passed, which means we did everything correctly. And that's it for this problem, and we'll see you next time.